Good, okay. I know I missed doing one of them, and then I also screwed up and missed half of one of them, but... Okay, so today, tomorrow... Sorry, I'm going to close that. That thing is driving me nuts. Today and tomorrow I want to really focus on... You guys with me?
Yeah.
Okay. We're going to focus on the word rationals, which is really the fancy math word for fractions. Okay. I don't actually know why there's a discrepancy between the two. Like, why don't we just pick one word and go with it? But fractions are rationals. Fair enough? So, rationals, you may have heard of rationals before as like the types of numbers. Okay. Is a diagram like this, have you guys ever seen these before where we talk about the different groups of numbers? Like, natural numbers are like the 1, 2 through 5s. Integers means you can include negatives. Rational numbers then are anything that can be written as a fraction. So here's some examples. 3 over 4, that's a fraction. 0.75, although a decimal number can be written as a fraction, because it is 3 over 4, is minus 5 a fraction?
Yeah.
Yes, it is, if you make it minus 5 over 1.
But if it's 1 over minus 5, it's not.
Well, 1 over minus 5 is also still a fraction too.
So it's just a fraction. Basically any number can be.
Okay, well, most numbers, let me give you some examples of numbers that are not. Okay, pi is probably the best example of what's called an irrational number. Try as you might, there's no way to write pi as a fraction. Pi is one of those numbers where, maybe you've heard this phrase before, it doesn't terminate or repeat. Ever heard that phrasing before?
Yeah.
Like, if I were to give you the number 1.222 repeating, that should be able to be turned into a fraction. Or 0.5, it terminates, should be able to be written as a fraction. But 3.14159 blah, 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 no one has ever finished the blah, blah, blah to pi because it just keeps going. Does that make sense?
Did you do 3.14 over 1?
Okay, but technically that 3.14159 still needs to keep going. So I know you're telling me that you can make it that, but it doesn't deal with the fact that like it never actually ends. Does that work? So another example of an irrational number would be the number square root of 2. If you ever square root a number in your calculator, unless it happens by some random luck to be like the number 4 or 9 or 16, where they actually square root, the square root of 3 or the square root of 2 can't give you a whole number. And so it gives you one of those decimal numbers like 1.41 blah, blah, blah. And again, as soon as you get a blah, blah, blah that doesn't end a repeat, now it's not rational. Does that make sense?
Yeah.
So, long story short, today and from the rest of this unit, we're dealing with things that are fractions, only one big problem. We're not going to just do numbers. We're going to do, yeah, like the phrase would be equations, where we write like a function, like an equation on top of each other. So like I said, the two F words of math. So here's just another picture describing what rationals are. Rationals involve something on top of the fraction, something on the bottom. And one more thought, though. There's a general rule in math that you cannot divide by a number, the number 0. So for whatever reason, whatever's on the bottom of the fraction, we just have to make sure that it's not 0. Okay, let's do some examples. I'm fairly comfortable in saying that you guys have all learned how to do this with numbers before, because if I asked you to take 9 over 12 and turn it into 3 over 4, I think you could probably do that. How do you turn a 9 into a 3? Well, you divide by 3. How do you take a 12 and turn it into a 4? Divide by 3. Right. What you're doing is something very similar to factoring. Find something in common and just divide by that. That makes sense? So let's do this here. There are 3 m's on the top and 2 m's on the bottom. How many m's are in common?
2.
2 are in common. So you can almost write it as there's 3 on top, there's 2 on the bottom. 2 of them are in common, so if you cancel those 2, there's 1 left on the top. That makes sense? Here there's 4 t's and 1 t, so there's 1 t in common. So when you cancel that 1 t in common, there's 3 t's left. Only these t's are now on the bottom. So the answer to this would be m over t cubed. Does that make sense? Okay, one more thing. I doubt that the diploma writers would do this, but I need to be thorough. I don't want you to get a question wrong just because I glossed over a little point. There is an alternate way that they might write this. They might write it like this: MT minus 3. Okay, let me talk about this notation here. If you're ever given 1 over x, we can also write it as x to the negative 1 because there's 1x in the bottom. Okay. If I gave you 1 over x squared, that could, keep in mind this is just could, it could be written as x to the minus 2. This 2 because there's 2 x's. And the minus just implying that it's, the negative is because it's on the bottom of a fraction. You guys ever seen that before?
I have.
We do it in dash 1 a lot. I don't expect this in dash 2. I'm not specifically going to test you on this. I just want you to be, like, maybe have seen this before in case it comes up. Okay? But I would be content if you guys left your answer like that. That's what I would expect. So far, so good? Moving on. Okay, why don't you guys try these then? Actually, let's do them as a group. Why not? Is there a common number between 24 and 18? Okay, so then divide both by 6. So 24 divided by 6 is 4. 18 divided by 6 is 3. Do you guys see how this is similar to factoring? And then there's 2 a's on top and 3 on the bottom. So 2 of them can cancel. There's 1 left over.
3.
Yeah, the a's got to go on the bottom with a 3. Make sure you don't put the a on the top with the 4 because that's a completely different thing. 18 and 36. Actually better than that. I think all 18 is actually in common. So 18 and 36 gives you, I should make sure I'm clear on this. You cannot leave the top of a fraction blank. So you have to at least put a 1 on top. So like 1 over 2. And then hopefully you can do basic math in your head. If there's 7 on the bottom, 4 on top, there's 3 left over on the bottom. So far, so good? Okay, here's where we put our F words together. Yeah. So now what we need to do is we need to factor before we deal with the fractions. Okay. There's a rule in math that maybe you've heard or been told before. Math really is just a lot of rules, isn't it? But there's a rule in math that says you can cancel things, but only under certain conditions. Monomials can cancel monomials. Binomials can cancel binomials. But you can't have a monomial and a binomial cancel. You ever heard this sort of terminology before? Let me show you an example.
So only C can do it, right?
Well, we can actually play some tricks on A and B to make that work, but let me just show an example. Let's say that I told you that 3 plus 4 was over 2. Hopefully you'd agree the top right here is a binomial. There's 2 things there. And the bottom's a monomial. Here's what a lot of kids try to do. They try to take this 2 and this 4. They say they cancel. 4 and 2 becomes 2. And then they say, well, 3 plus 2 is 5. And they say the answer is 5. Now, that's very wrong, because hopefully before I do all this work, you know that 3 plus 4 equals 7. And then when you divide by 2, 7 over 2 and 5 are not the same thing. Does that make sense? So the key to solving one of these things is before you try doing some canceling, you got to factor. So let's try the top one. This top part right here, is there some commonality between a 15 and a 5? A 5. Okay. And is there some commonality between the 3 x's and the x?
Yeah.
1 x. Okay. So now I'm going to put in the remaining portion. So if I factor out a 5 from a 15, there should be 3 left. By the way, I'm not doing any canceling yet. I'm just purely factoring. And if I factor out one of the x's from the 3 that's up there, there should be 2 left. I can't take out 5x squared because this guy right here doesn't have 2 of them to cancel. Are you guys okay with the first step where I factored, but I only factored the top? Okay. The stuff in brackets is now untouchable. Okay. This 3, this x squared, and this minus 1, do not try to cancel it. You cannot. The reason why is it's a binomial. And unless you have another binomial exactly the same as it, it's no good. However, the monomial stuff, this 5x right here, and this 15x to the 3,
please come to the office for checkout.
That stuff can do some canceling.
Sarah Black Rabbit, please come to the office for checkout.
So 5 and 15, can that cancel at all?
Yeah.
You can divide both by 5, which means that you get a 1 over a 3. And then you have an x on the top and 3 on the bottom. So then there's 2 on the bottom. So that kind of deals with this stuff here and this stuff here, those monomials. And then the binomial is just stuck. Okay. And if it feels like you should be doing something more with it, you can't though. Okay. So then you're just left with a like 3x minus 1.
Why couldn't we just factor that 1 in?
And that's the last thing I'm going to suggest then.
3x squared.
Ooh, good catch. Thank you. Okay. Thank you for finding me that. Sorry, go ahead.
How many cancel 3x squared and 3x squared?
Well, see, here's where we can't. This 3x squared minus 1 is part of a binomial, and that's a 3x squared. It would be like me telling you that 3 minus 1 over 3, it would be like you canceling those and saying that the answer is minus 1. But I know that 3 minus 1 gives me 2 over 3. That's not how it would work. So that's a good point, though. Don't try to cancel these 3x squareds, but I can re-foil that 1 back in. So your final answer would be 3x squared minus 1 over 3x squared. If you're in my 20-1 class last year, we did this before, kind of. Like, this is probably not something that's brand new. It's just I think we need to spend some time rebuilding these skills again, though. Of, like I said, factoring, fractions. The F words. How am I doing so far? Does this make sense? Okay, I'm going to erase all this and then we'll try the next one. Let's go try B. So in question B, first before we do anything is we have to recognize that the top being a binomial needs to be factored. So 3 and 9 have a 3 in common. And y squared, they both have a y. So I can remove a 3y. Well, the 9 turns into a negative 3y. But I can't leave just nothing sitting right here. Good. Yeah, you got to leave a 1 so that 3y times 1 gives you that first 3y. And 3y times 3y, well, 3 and 3 is 9, and y gives y squared. And then on the bottom, I'm going to write it very select. I'm going to put it right over here just on purpose, just so you can kind of see them line up. Good. So like the 3 and the 6 can become a half, I guess. Y squared. Does that make sense? And then on the top, well, you still have that 1 minus 3y. Now, these examples I've picked so far, there's always been a 1 left on top. But hypothetically, let's say there was a 2 or a 3 in this location. You'd have to refoil that number back in again. So that's what makes... Do you guys see why we spent last week working on foiling and factoring? Because those skills are going to be pretty critical. So, I mean, I guess if you refoil the 1 back in, it's just 1 minus 3y over 2y squared. Can somebody try to do this? Hey, there's a y. Hey, there's a y.
No.
Why not?
It's a binomial.
Yeah, monomial, binomial, but it's not correct. So don't do what I just suggested there. Good on that one? Okay, let me try one more. This one here, both are binomials. Okay. Now, I've made this one on purpose to try to illustrate just a slight thing that students might want to try to do. So I'm going to try to make a mistake on purpose and then see whether you guys can catch this. Okay. On the top right here, in common between 6 and 8 would be the number 2. And at the bottom, there's an m in both of them, so I can pull out an m. And then when you're done, that would leave you with 3m minus 4. And then on the bottom, you could say, well, both of these involve m, so I guess I could take out m squared, and it would leave you with 3 minus 4. And then someone might say, hey, look, boy, that looks...
No, because they're around common.
You see how one of them is 3m minus 4, and the other one is just 3 minus 4? It has, if you're going to try to cancel a binomial, binomial canceling is valid, but it has to literally be the exact same thing. So don't do what I did there. So let's just back up a step. Good, that's what I was going to point out on this one here. It may be smarter for this one right here to combine those like terms, but I do that one on purpose just to try to show you where you can't cancel.
Kevin Cleaver, can you please call 100? Kevin Cleaver, please call 100.
If you have 3 of something and you subtract 4 of something, you have negative 1 of something. So you'll have like negative 1 m squared. What can cancel?
Actually, should you do the...
Or what?
Is that top part right?
The top part is correct.
Oh.
The top part was correct, but I was trying to make a mistake on the bottom part to illustrate a point. Did I do that effectively? Did you guys get what I was going for there? Okay, so based on this being correct, what can cancel? There's only one thing. Just a single m. Yeah, there's one m on the top and 2 of them on the bottom. So you could like cancel this m and get rid of the squared version of that. This would be a time where you now probably should re-FOIL this back together. So like re-times those. Kind of sucks because you just spent all that time factoring. So by the time you're done, you're going to have 6m minus 8 all over negative m.
Then you can't do anything.
You can't do anything more there. What I would like to do, though, is point out a trick that they might do on the diploma. For me, I'm content with you stopping here, but I'd like to show you a trick they might play. Have I shown you guys before that the fact that like the number negative 3 over 4 is the same as 3 over negative 4? Have I shown you that sort of concept before, that it doesn't really matter who gets the negative sign? Okay, what they may do on the diploma, just to try to mess with you, is you see how there's a negative on the bottom number right here? They might write it like this instead. They might put a positive m on the bottom, and they might make it negative 6m plus 8.
Yeah, it's the same thing.
That's the same thing. See how it's really tricky? I know, isn't it, right? Because what they might do is they might take the negative off of the bottom, put the negative on the top, and then they'd like FOIL that negative into both terms.
That's not fair.
Okay, I wouldn't expect you to have to do that. Like if you left your answer right here, that would be valid. But part of what I feel like my job is to try to show you those little things so that you get the diploma questions right. So they could do that. I don't know if they will, but they could. How am I doing so far? Does this make sense? Okay. I just got some slides here then, just kind of re-going over some of the things we talked about. This one right here just shows the idea that like you cannot cancel these x squareds because this is part of a binomial. That's part of a trinomial. That's not the same thing. Okay, a bit of a side note here. You guys remember when I talked about fractions a little while earlier today, I mentioned that there's one number that you cannot divide by? 0. They may ask a question where they ask you something called a non-permissible value. A non-permissible value basically is exactly like the words would describe them to be. Non, so something not permissible, not something allowed number. That makes sense? What number could this x right here not be?
0.
4.
4? Oh, 4. Okay.
Because if it was 4, then 4 minus 4 would give you 0, and that's where the problem comes in. Does that make sense? So if they ever ask you for a non-permissible value, they're really asking you what number makes the bottom of the fraction 0, and it just means that like x cannot be 4. That's all.
Oh, so we have to solve it.
No, we don't need to try to solve or do anything here. It's just asking us what is the not allowable number. That's all. Let's try the other one here. Anyone have any ideas what numbers you couldn't use for x?
5.
5 wouldn't work, yeah. Because if you did 5, it would be 5 squared, that's 25, minus 5 times 5.
It's 25.
well, 25 minus 25 would then give you 0. So therefore, you'd say that x cannot be 5. There's actually one more.
0
Good. 0 is also right. Because 0
times 0.
squared is 0. Minus 5 times 0, well, that's also 0. So 0 minus 0 would give you 0. So it's fairly likely that on the diploma, they're going to ask you about non-permissible values. It's quite easy. If it's multiple choice, all you have to do is take the 4 multiple choice answers they give you and try to see whether you can actually use them in the fraction, only on the bottom though. And if you can't on the bottom, then that's the non-permissible value. So.
And it can't be like a non-permissible if it's on the top.
Yeah, so like on the top right here, if the top of the fraction is 0, that's fine. The only thing you can't do is try to divide a fraction by 0. Does that work? Other important notes here. So just like we were saying, the bottom of the fraction cannot be 0. The top of the fraction can, but not the bottom. And other note here, always try to reduce to lowest terms. So like if you end up with like say 5 over 100 or 3 over 6 or 2 over 4, always aim for the lowest possible value you can get in terms of fractions. All right, I think 3 slides left, is that right? Okay, well, is it okay? Can I finish the 3 slides and then give you guys a break? You guys are able to last that long? Okay. Okay, so we're going to do 2 things on this question. We're going to do the non-permissible value thing, and we're going to simplify. So let's do the non-permissible part first. What number can this x right here not be? Well, if you tried making it 0, 2 minus 6 times 0 would give you 2 minus nothing, which would give you 2. So actually, 0 is okay.
I don't know.
Okay, so if you're stumped on this, treat it like algebra. Write a sentence out like this. 2 minus 6x is not allowed to be 0. Now this is where the algebra skills come in. How do you get x by itself?
You have a minus that bring a 2 over.
Okay, so then minus 6x is not allowed to be minus 2. And then divide by minus 6. So then x is not allowed to be whatever minus 2 over minus 6 is, which is a third, 0.3. So what we've done here is we haven't actually solved it. All we've done is we've said this is the one number that x can't be. X cannot be 1/3. Because if it was, you'd be divided by 0. So far, so good? The other thing we have to do, though, is we actually have to simplify this thing as well. So I'll do that over to the side here, but maybe you guys want to do it below. I'll just do it in this area. Minus 18, you can't really do anything with. Can you factor anything out of a 2 and a 6? Okay. So if you factor out a 2, it leaves you with a 1 minus 3x. And 18 and 2, they can divide. Okay, so your final answer would be negative 9 over 1 minus 3x. However, I just want to make sure you've seen this a few times. It is entirely possible that just to mess with you, the question might be written slightly differently. Do you see how one part of your fraction has a negative on it? The negative 9? They could write it as positive 9, throw the negative on the bottom, and make it negative 1 with a plus 3x. They could. Does that work? Okay, let's try the next one. Okay, what's the one number that x cannot be? Well, 4 is actually okay, because 4 times 4 would give you 16. That's okay. 0, yeah. And if you were really stumped on this, here's a way you can prove it. You would say that 4x cannot be ever allowed to be 0. And then you'd divide by 4. Well, 0 divided by 4 is 0. Yeah. So. Okay, more important part here. I'll go the other way this time. Let's see whether we can reduce this. The top has a 2 in common. So you could factor out the 2, and it would leave you with 1 minus x over 4x. And then you'd cancel the x's.
No, it's can't.
Good, yeah, okay. You can't cancel those binomials. Well, I'm glad you caught.
You just taught us that that's not okay.
I'm seeing when you're paying attention. I'm glad you're going, Good, okay. What can I cancel though? Yeah, like the 2 and the 4 can become a half. So your final answer is 1 minus x over 2x.
Wait, you can take out it's not going to be one bracket.
Well, yeah, I guess you could do that. Like there's a 1 there, but then like, isn't that 1 just going to foil back into this little guy and just make it, that makes sense? So if you're left with a 1, don't worry about it. If you're left with a 2 or a 3 or a 4, then refoil it back. So probably the way they'd put it on the diploma is that they'd make it look like this, 1 minus x over 2x.
Could they write it as 1 plus x and then over minus 2x?
Close. They'd have to make it negative 1 plus x over minus 2x. I'm not sure whether you said the first negative. Okay, yeah. What you could do, I mean, if you were really being a jerk, is you could say, well, let's put a negative on this, flip these guys' signs, and on that one there. I don't know why they'd do that. I could totally see them doing the other examples I had there where there is a negative and they just shift the negative from the bottom to the top, from the top to the bottom. But there isn't actually a negative in this one right here, so yeah. That'd be a real jerk move, though. Okay, let's see whether these things are equivalent to each other.
How do you do that?
Well, in order to figure out whether two things are equivalent, the best way of doing that is to try to make them as simplified as possible. And then if they're the same when they're simplified, then they're equivalent. Let me give you an example. If I gave you 1 over 2, would you guys agree that that's the same thing as 10 over 20? Because really the 10 over 20 just needs to be divided by 10 to make that. So we want to do the same thing here. Let's try to simplify. Can I cancel anything on this one here? Actually, not whatsoever. No. What about here? I could factor out a 5, and it would give me a 1 minus x over 3x. Can anything cancel? Is this the same as that? Not even close. But if it was the exact same, the phrase we'd use is equivalent. Okay, last example. So these ones right here are kind of the most challenging ones I've got. You know what? Can I lie? Can we take our break here and then do these last two? Let's take a break now. Keep going here. Okay, so Lisa asked, as you guys were leaving, I don't know that you heard, but what makes this one more challenging is that the top is a binomial, the bottom is a trinomial, which means that you still have to be able to do all of those sorts of factoring skills of simple, complex. This guy right here, I'm gonna work off to the side in green. Can I just go straight to like 2 different things there? I have to do like the long method. So kind of stinks. Like I said, this is why you've got to do fractions and factoring.
1 plus 1 equals 1?
And we need it to times to give minus 20. Let me know if you can think of a number combo that could pull that off.
None. Do we have to do the quadratic?
No, this is factorable.
Is it?
Yeah.
Okay. Okay.
Okay, what numbers times to give 20?
4 and 5.
Thank you, sir. Which one's negative, though?
Minus 5. Minus 4.
4.
Good. So, like, go with a plus 5 and a minus 4. Oh, boy. Okay, so we still need to finish the factoring part of it, though. So, by the way, the answer is not x plus 5, x minus 4. Don't do that.
Because there's a 2 in front.
Because there's a 2 in front. So 2x squared plus 5x minus 4x minus 10.
I'm going to switch my order so it's easier.
Okay, switch the order if you want.
Can you simplify this first? Before we throw it back underneath the fraction?
Not really, no, unfortunately. We do need to break it back into the 2 different portions. So you should be able to take out an x and a 2x plus 5 and a minus 2 and a 2x plus 5. Long story short, you should get an x minus 2 as one of them And a 2x plus 5 is the other one.
Hey!
Hey.
The top one!
Whoa, we're not quite there yet, but yeah, you're right. Everybody okay with the green factoring portion?
Mm-hmm.
Okay, at least it's a little ahead of me. The top thing can also be factored. I'll do that in red. 3x minus 6 can be turned into 3 with the bracket x minus 2.
Does that mean we have
Oh, the cancel.
binomial?
It does, yeah, good. I think some of you guys are starting to see how this fits together. So when we're done, we're going to have 3 over x minus 2 and x minus 2, 2x plus 5. So now we do have binomials that are the exact same as each other. So those can cancel. So final answer is 3 over 2x plus 5.
That wasn't too bad. That was just more steps.
It is, and this is where I think that's what most people get frustrated with, is that factoring on its own is a challenging skill. Fractions on their own are not exactly enjoyable. So, but like if you can take it like little step by little step, I know you guys possess all these skills. It's putting it all together now. That's the hardest part.
Whoa, wait.
Yeah, for sure.
How do you do the...
Oh, no, I didn't.
I thought we were on the second one.
Okay. You're good?
Yeah.
Okay. Okay, last one. Yeah.
Was there like nothing, there's like nothing to do? Would we have to do plus 0?
Did you
Well-
minus the 1?
Okay, so in terms of factoring, there is actually one type of factoring you can do. It's on the bottom. X squared minus 1 is a difference of squares. Because x squared can be square rooted, and 1 can be square rooted. So the only thing you can do on the bottom here is make this guy be an x plus 1 and an x minus 1.
So would 1 minus x be the same?
Okay, so here's the issue then. Is positive 1 and negative x the same thing as positive x and negative 1? Are they the exact same?
No. What?
No. Like, because what you want to do, you want to cancel this guy with that one.
No, that doesn't work.
It doesn't, but
the 1 and the 1.
okay, here's the thing though. If you use, I've been hinting at this all day today, that little trick with negative stuff, it is possible.
Huh?
So
To be negative.
here's what you could do, is you could take, like, say, this top guy right here and make it negative. And so what would end up happening is you'd get, like, say, you'd get negative 1 and plus x.
But wouldn't that have to switch on the bottom ones?
Well, here's the nifty thing about the bottom. Rather than switching this guy over here, let's switch the first one. So what we'll do is we'll switch this one right here to also be negative, which will make it negative x plus 1. Oh, sorry, not negative x plus 1. Negative x minus 1. And then we'll leave the back one of the two. And now, I know they're in the wrong order, but let's read them out. This one has a negative 1. That one has a negative 1.
Wouldn't that be?
This one has an x. That one has an x.
I don't like that.
I don't like that.
I know, it's
It's
frustrating.
funny you just start throwing negatives all over the place.
Well, so long as you throw a negative on the top and the bottom, making it like a double negative, then it would be valid. Because wouldn't it be fair to say that like 1/2 is the same thing as negative 1 over negative 2? I know you'd never do that because it doesn't seem purposeful. This is where they might try to trick you. Is if they give you 1 minus x and x minus 1, they are similar. But in order to make this trick work here, take the negative and kind of flip those ones around. Take this negative and flip those ones around, but leave that one sitting there so that this guy and this guy can cancel. So then your final answer is 1 over a negative x and a negative 1. There are other ways of writing this, but that's probably the best one right now.
They're not like the Sphinx trying to stop us from entering a pyramid. We're supposed to pass this.
I agree. Don't get me wrong, I don't disagree with you. I think I'd be remiss as your teacher if I didn't try to show you all the little, you know what I mean? So,
Thanks, Joe. Thinking about it.
well, it sucks though, right? Because it's like, it's frustrating.
It's backwards.
So, okay. how do you guys feel minus that last little twist? Because that last little twist is definitely like a exception kind of thing.
It's not too hard.
Okay, my suggestion here then, grab one of the duo tanks, and I mean, I don't want to put a number on you for today, but maybe if I were to suggest, try like 8 questions.
Okay.
And I would just do them on the simplifying page. So the second last page on simplifying rationals, try to pick a good variety. And if you feel like you've got some good questions that you're going to want to highlight for the end of the week, you'll probably highlight them right now. So if you guys can finish those 8 questions, after that, you guys can take off if you want. So, I mean, don't do all the easy ones, right? Like, definitely try to pick up some tough ones on the back side of the page.
Okay, I'm gonna start out with the easy one.
But, like, I don't know. At some point, you should do, like, say, 52 and 47 and 44. Some of those. So do a simplifying rationals worksheet. Pick, I don't know, 8 or so. Okay. Tomorrow I'll have an assignment for you guys so that you can work on that.